Hello everyone, this is Rakshita. I'm of CSEI Department 7 SEM. I'm here to talk about advanced AI/ML techniques like KNN kernel, RBF kernel, and case-based reasoning. Agenda is Introduction to Advanced AI/ML Techniques, Overview of KNN, Radial-Based Function, Kernel in Machine Learning, Case-Based Reasoning Principles and Application, Use Case in Industry, Comparative Analysis, Conclusion, and Introduction to Advanced AI/ML. Artificial intelligence and machine learning are continually evolving with techniques like KNN, RBEF, kernel, and CBR gaining prominence. These methods are crucial for solving complex problems in diverse fields such as healthcare, finance, and autonomous systems. This presentation deals into the working principle, application, and comparative advantage. Overview of K-nearest neighbors. KNN is a simple instant-based learning algorithm used for classification regression. It relies on the principle of finding the k-closed data points in the feature space. Key features are non-parametric and lazy learning algorithm, suitable for small to medium datasets, sensitive to feature scaling and noisy data. How can an algorithm work? First, we have to choose the k value and calculate the distance between the k value and the query value, of which the value now we have to find whether which distance it does belong. Identify the k nearest algorithm, and for classification, assign the majority class label. For regression, compute the average value. In classification, this becomes like based on the voting system. If many of them voted for positive, then that particular class go to positive class. If else, it goes to negative class. Advantages is simple, interpretable. Disadvantage, computational expensive for large data sets. Application is image recognition, handwritten digital classification, recommender systems like finding similar users or items, anomaly detection, identifying outliers in database, medical diagnosis, classifying diseases based on symptoms. Radial basis function kernel. The RBF kernel is a popular kernel function used in SVM, support vector machines, and other algorithms to transfer data into higher dimensional space, where data are scattered in lots of space. To do for in linear algorithms, you can use linear search, or but in non-linear mapping of data, we use radial basis function kernel. For linear data, we use linear kernel. The mathematical representation is e to the power of x 1 by sigma square. E to the power is 1, e to the power 1 by 2 sigma square. Derivative of x is a mathematical representation where y is a parameter controlling the smoothness. Key properties is non-linear mapping of input data, infinite dimensional feature space. RBF kernel in machine learning. Advantages is handles non-linear relationship effectively, works well with high-dimensional data, can model complex decision boundaries. Challenges are require parameter tuning for Y and sigma in SVM, prone to overfitting with appropriate parameter. Applications of RBF kernel. Support vector machine, classification task, and healthcare and finance. How does even support vector machines work? First, there are a lot of data scattered in an plate or in an environment. We have to classify between whether the data is spam or not spam. So in SVM is we have to draw a hyperlink between two datas, that is spam or not spam. So this helps to classify by using RBF kernel. First, we are organizing data of n dimension into one dimension, and we are drawing plane, hyperplane. And if by calculating the distances, and if the distance between the two points belongs to the hyperplane, then it is considered as to which data set it does belong, like spam or non-spam. Kernel ridge regression, predictive modeling, clustering, mapping data for better cluster separation, anomaly detection, identifying rare events in datasets. In clusters also we will be using where Cluster is grouping a similar database or grouping the similar datas into one clusters. Case-based reasoning. CBR is a problem-solving paradigm that uses past cases to solve new problems by finding the most similar case in a case. It is not. It does not provide any solutions. It's like it does not provide any new algorithm or anything. It will just solve the problem by based on the similar cases that has been solved and updated in the database. It consists of a library. In that library there will be somebody to design problems is defined. In that you're gonna retrieve similar cases and reuse the information to adapt to the new problem, revise the proposed solution, retain the new solution for future use. This is case-based reasoning. Advantages and challenges are mimics human problem solving, adaptable to new situation, continuously improve with new cases, require a well-structured case base is a challenge, sensitive to quality and relevance of case, computationally intensive for large case bases. Application of CBR, help desk system, legal systems, diagnostic system, design and planning, engineering design reuse, identifying design disease based on previous cases, case law retrieval and analysis, automated customer support like chatbots. You can use the CBR method where it's already pre-programmed, so you if they ask the similar question, they can give a previous answer also. Use case in industry. Fraud detection in banking is most in KNN, RBF kernel, medical imaging for tumor classification, automated customer supports. Conclusion is KNN, RBF kernel, and CBR are a versatile AML techniques. These applications span diverse industries, feature direction and hybrid approaches, improved computational efficiency, broader adoption. Thank you for everyone watching this video. I would like this very helpful for your upcoming studies.